That's okay. So first of all, you gotta say hi, Sam. Can you say hi, Sam? I need to be louder.
Hi, Sam.
Right? We love you, Sam. Hi, Sam. Right? Here we go. This is for you. So what we're doing here is doing assignment 4.4. So we have an equation. I want to analyze it and graph it with calculus. So I'm going to take the derivative. Did you do this already? And get 3x squared, take away 6x. Take that and make it equal to 0, and then I'm going to solve by factoring. And then when I solve it, the two critical numbers are at 0 and 2. So I'm going to draw a number line, and only 0 and 2 will be on the number line. And it's important to know that you go back to the derivative, not the function, to know the signs. So plug in any negative number, and the answer is going to be positive. Plug in positive 1, and the answer is going to be negative. And plug in any number bigger than 2, and the answer is positive. So what did we just find? This function is increasing from negative infinity to 0. It's decreasing from 0 to 2, and increasing again from 2 to infinity. Whenever the signs change, it creates a turning point. So when we go from increasing to decreasing, it creates a maximum. So we have a relative max when x equals 0. Now to find the y value, you go back to the function, and when you put in 0 for x, you're just left with 5. So at 0, 5, we have a relative max. We also have a minimum. So at 2, what's happening? It goes decreasing to increasing. And when you change directions, for this, it creates a minimum. So I'm going to plug in 2. To find the y value, I go back to the beginning again. So 2 cubed is 8. 2 squared is 4 times negative 3 is negative 12. So 8 take away 12 plus 5. I think that whole thing is 1. Is that right? So we have a minimum at 2 and 1. We're still not done. I'm going to do the second derivative and then I'll graph it. So the second derivative would be 6x subtract 6. I make it equal to 0 and solve it. And you'll find that x equals 1. When I do a number line for the second derivative, the only number I'm going to put down is 1. If I plug in any number less than 1, like 0, the answer is negative. Plug in a number bigger than 1, the answer is positive. So where is it concave up? From 1 to infinity. Where is it concave down? From negative infinity to 1. And do you see a sign change? So that means we have a point of inflection. At what number did it change concavity? 1. When I plug 1 into here, 1 take away 3 plus 5, that's 3, right? So we have a point of inflection at 3. We are now ready to finish this. So we're now going to put all this work together and graph this function using calculus. So we just did 1 and 3. That's a point of inflection. 0 and 5. And 2 and 1. See how I put those points down? And the y-intercept's already on there. Those are the only points I'm going to use. I'm also going to understand the end behavior. How do I get the end behavior of this? It's from the power term. What do you notice about the power term? Is it positive or negative? So the right end goes up, and the odd exponent means the left end goes down. So let's make a connection here. So first of all, what's happening from negative infinity to 0? Is it increasing or decreasing? When it's increasing, with a frown or a smile? With a frown. So, remember I said don't worry about the x-intercepts? Is the left end going down? Is it increasing? And is it frowning? See how we put it together? Now, what happens after this point? is it's no longer increasing, but after 0 it is now decreasing. But when it decreases, we're still doing what? So we're going to decrease, but still with a frown. So this whole thing is a frown up to the point of inflection. Now what happens at this point is it stops frowning and now it smiles, right? Now what do we know about this point down here? That's a relative minimum, and we know the right end is going up. So the last part would be smiling, and the right end goes up. And at the very end, we make sure it all actually fit. We said there's a maximum at 0.5. Yes? We said there's a minimum at 2.1. We said there's a point of inflection where instead of frowning, it smiles. We said the right end goes up and the left end goes down. Does it all fit? That is what we're doing. That. Got it? We're putting the pieces together. There's our Picasso. Number 2. Let me write down what number 2 is. I got it. So again, it's way better, right? If I let you do it and not me, just you nod along. Say yes, it's better. So I need you to write that down. I want you to understand the domain already is all real numbers. You know what? That. It's a polynomial. There's nothing that makes anything undefined. We're good. There's no holes, asymptotes, none of that. So I want you to take the first derivative. Find y prime, make it equal to 0 and solve it. Tell me where it's increasing and decreasing. Find the second derivative. Make it equal to 0. Make a number line. Tell me where it's concave up and down. Tell me the relative maximums and the relative minimums, right? Tell me if there's a point of inflection. We'll put it on a graph. We'll talk about the power term and end behavior at the end. And then we'll put it together and make our Picasso. You have to work through this. And again, I expect that you work together. I expect you talk to each other. I expect that you confirm that you agree that what the first derivative should look like. Make it equal to 0. Solve for x. You agree on it. Draw a number line for the first derivative. When we're done number 2, we'll graph 1 and 2 with their graphing calculator and see if it matches. Okay, so you have practice graphing with your calculator. Yes. Exactly. That's exactly. How many check marks and then divide it out of 45 and tell me the percent. That's it. For all 9 questions. Is this part of yours? Oh, okay. Well, there you go. Smart. Did you see the questions? All Math 3 honors. Get it, right? Hey. So it gives me a clue what I have to go back to, but also like, man. Woo. So did you take the first derivative equal to 0, solve it? How many answers did you get? How many critical numbers do you have? Do you get 2 numbers? So you took the first derivative. The derivative of 1 is 0. The derivative of negative x is negative 1. And this is negative 3x squared. So I'm going to make it equal to 0. I think something's going to happen here. If I add 1, and if I divide by 3, what happens? Can you take the square root of a negative number? It's imaginary, right? So that means we have no critical numbers. Now we're still going to have a number line. Is that okay? But you know what we call this? Monotonic, right? Like there's one sign only. So this whole function is either increasing or decreasing. Which one is it? Did you say increasing or decreasing? Because no matter what number I put in, the answer will always be negative. So this whole thing is decrease. Are there any turning points? So what do I have to do next is the second derivative. Go for it. So you still need to do a number line, because it still tells you, but we just found that there are no local extrema. No turning points. Can you do the second derivative? Can you make it equal to 0 and solve? You guys have to chart I was like your hope and believability factor. It's like, are we going to like play our best game ever, right? Enough. You are not just going to hit the crap out of me. You're going to make the other girl earn every single point, right? If they're going to win a point, they've earned it. You didn't just keep hitting it out because you felt like hitting it hard. You hit it hard once, but the second time, So when I take the second derivative, did you get negative 6x? And when you make it equal to 0, one answer is 0. Yes? So again, we're going to do a number line, but only for 0. So when I plug it back into the second derivative, every negative number will give you a positive answer, and then any positive answer will give you a negative answer. So can you see where it's concave up and down? Do we have a point of inflection? At what number? And when you plug 0 in back to the function, the answer is 0 and 1. We're ready to graph. Now, we're not worrying about the intercepts. So we're just worried about the other points. So the only point I'm going to focus in on is 0 and 1. This whole thing is increasing or decreasing? Good. And the first part is decreasing with a smile. Do you know how to do that? Do you see decreasing? Now don't be fooled by this little arrow up there, right? This is still decreasing and it's smiling. And then what happens? And it's still, in the whole way through it's decreasing, and here it changes, right? We got this. Number 3. Is this better than starting off the way we normally start off? Don't get used to it. You are still accountable to do your work without me. But it felt like a good day to like pull the reins back, right? You ever ride a horse? That's those leather things, right? That tell the horse to stop or go or left or right. Whoa. Since it is Cowboy Day, right? Ranchero Day. I know. Every time I say right, 0, right? Doesn't sound right. So again, we're doing number 3. We good? I got lots of paper. Don't cram. I got lots of paper. Don't cram. You gotta do what you gotta do. I got lots. Okay? So just keep going. Don't cram. Maybe a bet we'll give you graph paper. You got graph paper. So does Kushi. Graph paper. The power term? So the power term is positive, right? With an even exponent, so it's a touchdown, right? Like this Friday. For our team, I mean. What's that? The power term stuff? Or football stuff? All right. So again, someone's going to come through that door, so don't get scared. Can I start number 3? No. What? That's not nice. So, can we at least agree the 2 critical numbers are 0 and 3? Yes. All right. Remember to go back to the derivative. So if I plug in any negative number, it'll be a positive times a negative, which is negative. That's a skill, right? To plug in and quickly find the sign. Don't be hard on yourself if it's taking you slower. I think it takes time to build up the number sense to get that. If I plug in positive 1, again, it's a positive times a negative. And if I plug in any number bigger than 3. Did we agree on the increasing, decreasing? Is 0 a maximum or minimum? Did the sign change at 0? So it only changed that. And 3 is a minimum. So we only have a minimum, and that's when x equals 3. How do I find the y value? What do I have to do? Do you want me to do the hard work? 3 times 3 times 3 times 3 is 81. 3 times 3 is 9, and 4 is negative 36. And then 16. Like, it's not impossible, right? Is it 3 and 61? Did I do it right? I didn't do it right? Oh, wait a second. 3 times 3 times 3 is 27 times 4. That's 8 and 2. That's 108 and 81. I get negative 11. All right. Give me 2 chances. I can do it. Next, y prime. I'll let you keep working. Come on in. We've been expecting you.
Well,
Thank you so much.
Yes.
Sorry for the
You do it. Do your thing. There's 22 in here.
Great.
And 2 TAs.
You guys understand, Crippen? I'm from the County Office of Education. Every year the state of California asks us if you have received this present from your teacher, this textbook, that you can use both at home and at school. It's because of a law called the Whedon Act, which basically says that every student in the state of California will have to pay for the community. Have all of you got the textbook? Is there anybody that may have transferred, been absent that day, moved in from a different district that has not received?
All good.
We're on that.
Calculus rules.
They're calling it Mr. Pimentel Day. I don't know if that's true or not, but the spirit
It's the only day that I actually am dressed appropriately for. I mess them up. Watch tomorrow.
I know.
I wear black.
There you go. All right. So I'm asking you to find the second derivative. Can you find concavity, concave up or down? You're appreciating not a quiz right now, maybe not a quiz at all today. Appreciate going slower. That means I don't do it fast and you nod, right? You have to actually, the bumps and bruises. You talk to each other in your group. Confirm. Did you get 12x squared? Take away 24x? So when I factor it out at 12x, I'm left with x minus 2. I still get the answer 0 and 2. Did you get the answer 0 and 2? So those are critical numbers for concavity. So 0 and 2. So if I pick any negative number in here, right? A negative times a negative is positive. Pick positive one. And a positive times a negative is negative. And then pick a number bigger than 2. So how many points of inflection do I have? So at 0 and 2, can you find the y value that goes with them? And then we're going to graph. To find the y value, you go back to the function. So we have the function, the first derivative, and the second derivative. To find the y value of a point, you go back to the function. We're going to try to avoid saying the word like go back to the original or something like that. All right, we done? Daniel, we done? All the way through. Look at question number 4. Get a head start. I'm going to count by twos. Is that okay if I count by twos? Because one point is at 0 and 16. And then we have another point at 2 and negative 4. So I'm going to count by twos. And then 3 and negative 11. Which is going to be in the middle. So again, we're not worrying about the x-intercepts. So first I need to know what's happening to my graph. Is it increasing or decreasing? And it decreases all the way down to 3. But look at the concavity. It decreases with a smile to what number? Can you decrease with a smile? Do you know that concavity, sometimes it's difficult to see on a graphing calculator? Like sometimes it's obvious, but like the point where it changes concavity can be really subtle on a graphing calculator. You know, it's a little different. Like a turning point is obvious, but a point of inflection is a little bit more challenging to see on a graphing calculator. What happens after 60? It's still going down, but now with a frown. So what's happening after 2? It's no longer frowning, it's smiling, but it's still going down, but this time with a smile. Now it finishes smiling. So we can really smile. Right? And you can smile all the way home, right? And both ends go up. All right, can we use a graphing calculator and see how this looks like on our graphing calculator? We'll just do number 3 so we can keep going. Any of these you can practice right at home with your calculator to make sure we're okay. There are some people that left calculators in the back there. You have my permission to borrow them if you forgot your calculator and then put them back there if it's not yours. Did you hear me? You have my permission to borrow those calculators in the back and then put them back to the charging pods. If someone's going to leave their calculator there for a day or 2, we can borrow them. Did I say borrow okay? I know, it's the one word that brings out my beautiful Canadian accent. Okay. So I'm going to graph this. So I'm going to erase what I have. And then I'm going to type in x to the 4th. See, before calculus, you're just focused on intercepts and end behavior. Now you have so much more you can do without a calculator and understand. So I'm also going to change the window so you can see. So for this one, I'm just going to go -2 to 5 or something. But the y minimum, I'm going to make that look symmetric. I'm going to use -20 and +20 so I can try to see the points of inflection there. I might even do it bigger than that. See, I guess I want to see is, are you now starting to be aware of concavity when you look off a graph? Can you see when it smiles, it frowns, and then it smiled again? Now, do you know that that's obvious that that's a point of inflection? There's another point of inflection, but in here it's not so obvious, right? Like it's really subtle. Somewhere here it frowned and then changed to smile, but is it easy to see on the graph? Is it obvious where the turning point is? Do you see how it matches? Like what you're doing in here? Do you see how awesome you are? Concavity, increasing, decreasing, turning points, point of inflection. Like you're really working at an equation to know really how to graph it. Not just intercepts and end behavior, right? Like you really are working at it now. All right, let's keep working. Number 4. Number 4, f at x equals x squared subtract 2x subtract 8. It says find intercepts. What are the two types of intercepts to find? X-intercepts and y-intercepts. To find the x-intercepts, you make it equal to 0. I mean, you make the function equal to 0. We're going to factor it, and then we're going to solve it. so that we know we have an x-intercept at 4 and at negative 2. There's another type of intercept. So when I plug in 0, the answer is negative 8. So the other intercept's the y-intercept, and it's at 0 and negative 8. So we can't forget algebra, right? Like we know calculus, it's our new friend. We can't forget our old friend, algebra, that we know all the intercepts. If I asked you for the power term, what would you tell me it is? Which means both ends go up. If I asked you for the first derivative, would you go 2x subtract 2 equal to 0 and then solve the equation? See, what we can find here is the vertex without using negative b over 2a. So instead of doing negative b over 2a, what did we do? We took the derivative equal to 0. Guess where the vertex is? Because the vertex is a fancy word for a turning point, right? And in this case, we know the turning point is a relative minimum. So instead of using a formula, we went the first derivative equal to 0. So the x value is 1. How do you find the y value? And if you plug it in, the y value is negative 9. If I do the first derivative test, I would only use 1. If I plug into the first derivative, any negative number will be negative, or sorry, any number less than 1 will be negative. Any number bigger than 1 would be positive. So we got decreasing, increasing. Our vertex, which we know is a relative minimum. And actually, in this case, it's not relative, but absolute minimum. Like there's no other point lower than that. So we can even call it an absolute, because that is the lowest point in the whole graph. When I do second derivative, would it be surprising that the second derivative is just positive 2? Do you know what that means? That no matter what number you plug in, the answer is always going to be positive, which means the whole graph is concave, which we know. And then can we put it all together? It's not even on a piece of graph paper, so forgive me. See, there's something that you did in Math 2, a little bit of Math 3, that now in calculus, we now have totally conquered that thing, right? A parabola, a quadratic. Like it doesn't stand a chance. It's been pinned. It's over. We've got it from algebra, calculus, every way. It's over. It will never win. We will always win. Quadratic, parabola, it's over. Number 5. Let me find another piece of it. Do you notice that number 5, it looks very similar to number 4? Does it not? So, you know what the only difference is what are those bars called? Okay, so I'm going to draw the graph again. Do you know what those absolute value bars do? So instead of having anything below the x-axis, everything now is going to be above. So do you remember our vertex was at 1 and negative 9? It's now at 1 and... And instead of 0 and negative 8, it's now 0 and positive 8. Do you know what stays the same? Do you know what stays the same? Huh? The x-intercepts, right? So what would this graph look like? Well, do you remember it used to look like a big U? So the end behavior is the same. Both ends are going up. But do you remember this part? Like, I'll go like little, like whatever, like this part here. Instead of being below, that dotted line now is reflected up. So what did those absolute value bars do? Whatever's below gets flipped up, and now that's what a parabola looks like when you put bars on the outside. All right, number 6. Now it's going to get real. Do we now have a polynomial in number 6? No! You know what we call that when it's a fraction like that? Now we have a rational. So we have 2x squared over x squared plus 3. We also are given the second derivative. Are we given the first derivative? No. We still need the first derivative. All right, write it down. Before we do any calculus, what do we know about this function before we do calculus? Any idea of what we know? Before calculus, I know this is continuous. Do you know it's continuous? There are no holes, no asymptotes. If you take the denominator equal to 0 and try to solve it, it would only give you imaginary answers. Number sense, no matter what number I plug in, the answer is always going to be positive. It's impossible to get a 0 in the bottom, yes? So what do I know? It's continuous. You know what else I know? It's the end behavior. What's the power on top and the bottom? So when I divide it, what number is that? The ends are going to what number? And another way of saying that, there's a horizontal asymptote at. I also know something about the x-intercept. Take the top equal to, what's the answer? Yay. So there's an x-intercept where? And what kind of exponent is it? Even, which means what happens at 0? Cross? Bumps, right? Guess what the y-intercept then is? If the x is 0, then the... Man, let's get going. We already did like so much without calculus. We know the end behavior, we know the intercept, we know what happens at that intercept, right? What we don't know yet is increasing and decreasing, if there's any turning points, and concavity, but we'll get there. So to summarize, at 0, 0, it touches, and y equals 2 is a horizontal asymptote, and there's no asymptotes or no vertical asymptotes or holes. I wonder if we could do the first derivative. Do you know what rule I have to do for the first derivative? I know you know it. It's the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. Now, just so you know, I need to take the top equal to 0. I need to take the top of the derivative and make it equal to 0. Now, the good news is, when I decided to distribute and combine like terms, what's going to happen? What are you left with? Do you notice we're only left with 12x? Can you do that work with me? Like when I distributed and looked, they eliminated. So when I make it equal to 0, what's the only critical number? And again, there's nothing that makes the denominator undefined. So the only critical number is at 0. So what really is the numerator? The numerator is really only 12x. So when I plug in a negative number, the numerator is negative, and the denominator is always positive. So negative divided by a positive is, and if I plug in a positive answer, the top is positive and the bottom's positive, so what do we know? So, and we knew this already, by the way, it goes decreasing to increasing, it creates a minimum. Guess what happens when something touches and doesn't cross over? Right? What does it look like on the graph? It creates a turning point. All right, last thing. Then we're going to graph. Do you see the second derivative? Only look at the top. You know what I'm going to do at the top? Tell me what makes the top 0 and use number sense. Don't make it equal to 0 and do 100 steps. Look, what number would you plug in for x that would make the top 0? 1. Because 1 squared take away 1 is? What else would make the top 0? Not just positive 1, but? Hey, we got this. So, this was the first derivative. Do you know what the second derivative is going to look like? What two numbers am I going to include? Negative 1 and positive 1. And now I need to plug in numbers. Now I'm going to tell you again, look carefully. No matter what number you plug into the denominator, when you square it, the answer is always going to be positive. So all you got to do is focus on the top. So if you put in negative 1 billion and do the work, that negative 36 is going to make the whole top negative. So a negative divided by a positive is negative. When I plug in 0, I get a negative times a negative, which is positive. And then when I plug in positive a billion, that negative 36 makes it again negative. So what does the concavity look like? Concave down, concave, concave down. That means we have a point of inflection at negative 1 and at positive 1. Where do I go to find the y value of these point of inflection? Where do I find the y value? Back to the function, right? Not the original. If you plug in 1, it's not bad. 1 makes it 2 over 4. I'm pretty sure that's a half. Guess what negative 1 does? The same. So positive 1 and negative 1 give you the answer what? 1/2. Can we graph this? Let's put it all together. I'm going to give you a moment. And I want you to feel amazing. Like the work you're doing. Some of you hated graphing 2 years ago. And when you think of Math 3 honors and calculus, how much effort have I put into graphing so you feel better? And you're not going to fall in love with it yet. Maybe it takes time to really fall in love. Maybe it's not puppy love. You know? Maybe it's more of an enduring love. Graphing.
Are you looking at the HV sign? You're looking at the palm. What's this? Huh? Oh, okay, go do it. You guys there? Yeah. The bill support is the cover sheet, right? We got what period it is? Period 7, period 4. Perfect.
Can you not forget there's a horizontal asymptote, right? We said that at the beginning. So if I was going to start 0, 0, or the other points, 1.5 and negative 1 and 1/2, yay? And what else? We know the ends go to that, right? The question is, do they smile or frown? And the other question is it increasing or decreasing? We're just putting it all together. Or believe in ourselves? We're thinking, this is amazing how all these pieces put together without a graphing calculator. That's what I think too. Now, because aren't the numbers relatively small that we care about? So I'm going to count by halves. I hope that's okay with you. So every other is going to be 1. Is that okay? That way I feel better about the graph. Do you understand why I'm counting by halves? Do you understand who controls the scale of a graph? You do. You're in control. So we have a point at 0, 0. We have another point at 1 and a half, and negative 1 and a half. And I said there's an asymptote at what number? We know this point at the bottom is a minimum, right? We know it's going to turn there. The question is how it's going to turn. So first it's decreasing with a frown. Can you decrease with a frown? Whoop, there it is. Do you see how this is decreasing with a frown? And I notice the ends are going to the asymptote. What happens between negative 1 and positive 1? It smiles, and what's in the middle of it? A minimum. Can you make it smile? And then what's the end part? From 1 on. It increases with a what do you think? Do you believe in yourself about looking at all those parts, right? And on your own, I'm not going to do it right now. On your own, if you typed it into your calculator and changed the window, it's good practice. You can see, right, how good we're doing. Number 7. Again, if you need another piece of graph paper, I think it's Yvette or Kushi's got some graph paper. No, I got graph paper back there. Okay, I want you to write it down. I don't want you to think class is over, because that drives me crazy. We got at least 1 or 2 more good questions left to give your best effort. Your A game. I need you to write down question number 7. Okay, I'm going to start with no calculus. So, pre-calculus, math 3 honors. What do I already know about the function? So first, is it a continuous function?
No.
At what number is it not continuous? Why? Because if I plug in 0, the denominator is 0, it's undefined. Is there any way to remove that discontinuity? So that means it's an asymptote, not a whole. Got it? So we already know there's an asymptote at x equals a. Do we have any intercepts? What happens if I take the top equal to 0 and solve it? In your head. Imaginary. X squared plus 1 equals 0, right? In your head, imaginary. Any x-intercepts. Okay, what's the other type of intercept? Plug in 0 for x. How about what happens when you go 1 divided by 0? So are there any x-intercepts or y-intercepts? So far I've said there's a vertical asymptote at 0, not continuous obviously. What's the end behavior? Power over power. What do you got? X squared over 2x. That's 1/2 x, right? So if I say graph the line 1/2 x, what's it doing? It goes up to the right and down to the, now let's do calculus. We know the asymptote, no intercepts, goes up to the right and down to the left. Now I need to know calculus. Where is it increasing and decreasing? Are there any turning points? Concave up, concave down. These are a point of inflection. Oh, it says there are no points of inflection. That means the concavity doesn't change. Or it might mean that where the concavity changes, the derivative doesn't exist. Hey, the rule I have to do here is the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. Now, I'm only going to look at the top. So if I just look at the top of the derivative, I'm going to make it equal to 0. I get 2x squared minus 2 equals 0. When I solve this, if I factor out a 2, will it be obvious the two answers are positive and negative 1? So I'm going to do a number line for the first derivative. Negative 1 and positive 1. If I put in a big negative number, negative 1 billion, this will be positive. If I plug in 0 or a half, the answer is going to be, and if I plug in positive, do you see any turning points here? What does negative 1 create? What does positive 1 create? So we have a relative max at what x value? And we have a relative minimum at what x value? How do I find the y values that go with them? Where do I go? To find the y values, you go back to the function, right? What number am I going to plug in? Negative 1. Do it. Do mental math. What's the y value? Next, plug in positive 1. Mental math. Can you get the y value? Both are nice answers to put on a graph. I got the maximum at negative 1, and the minimum at 1 and 1. A little confusing, right? Because you think the maximum should be higher than the other, but it's a turning point, right? So in its area, this will be a high point, and in its area, this will be a low point. We're still going to do the second derivative. Now remember the first derivative, the top is 2x squared subtract 2. So the bottom is now 4x squared times the derivative of the top, which is 4x. So let me remind you again. It's 2x squared, take away 2, and on the bottom, when you square it out, is 4x squared. That's the first derivative. So what's the second derivative? So the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. So I just care about the top. The bottom, 0 is an asymptote. That's the only bad answer that would make it undefined. We already have 0 as an asymptote. So the top see, 2 times 8, 16, plus 16x. So these are going to cross out. So when I make it equal to 0, what's the only answer for the top? So, remember we said there's no points of inflection. We still need 0. 0 is an asymptote. The bottom will always be positive. And the top, so what we have is 16x over 16x to the fourth. We can reduce it down. That's 1 over x cubed. If I plug in a negative answer, it's negative. If I plug in a positive answer, it's positive. Concave down and then concave up. Now we graph. I'm sure you would have passed the quiz today. But it's nice to double check, right? We have an asymptote at 0. Remember the end behavior? And the concavity. So first, this function increases to -1. It increases with a frown. Can you increase with a frown? And then what happens after that? It increases with a frown. It stays frowning, but now it's going to decrease. How about on the other side? So after 0, it's again decreasing, but this time with a smile. So it decreases with a smile, and then what happens? It now increases, but still smiles. So you get a full smile there. And you see the end behavior. No intercepts. We have 2 turning points. So what's the relative maximum and the relative minimum? And there's no there's no point of inflection because the concavity changes at the asymptote. All right, I'm going to stop there. Sam, we'll see you soon.